Hello, welcome to Principal AI's System Design video series. Today we are going to look at a very specific problem, design of a distributed key value store with concurrency support. Let us look at the problem statement. The problem statement tells us that we have to design a key value store. Both read and writes to this store should be async operations and should happen in the order. Reads are 3x of writes, which indicates that it is a fairly write-heavy operation. In addition to this, it should be possible to subscribe to change in value of a particular key. The hints to solve this are pretty much in the problem itself. Best way to ensure async operations is to queue them and use a pool of workers. To ensure that order is maintained for a given key, we can always use sharding on key. We create a service store service which supports three operations: read, write, and listen. Sync, this is async operations they have to provide a callback, which could be some response RPC or webhook, etc. There are standard patterns for this. We employ three queues. First queue is for both read and write. Since we need to maintain order, it is important that they get written to the same queue. We shard the workers on the key, which means the same worker will get both read and write messages in the order. This worker is responsible for maintaining the state to persistence layer. Also, the worker will write to the reply queue after writing to the database. For every write, the worker will also check if the value was changed and send a notification reply on the third queue. The store service will be responsible for calling the notification callbacks. Read logic is relatively simple. Read from DB and write the value to the reply queue. Either of these steps can fail, in which case entire operation should be seen as failure and retried. For write, the DB write and write to queue should happen in a transaction. We do not want to write to DB but fail to write to queue. This sort of atomic behavior can be achieved to multiple methods. One of the ways is to use an outbox table, and queue is populated from the outbox table. To achieve atomicity, here is challenge. The worker might write the message to queue but might fail to update the outbox table. This problem can be solved through idempotency. Each message will have an idempotency key. The queue consumer will be responsible for ensuring idempotency. That is, if the same message gets delivered multiple times, it will not be processed multiple times, but rather ignored. This is easier said than done, as the receivers also will have to solve the same problem of atomically doing idempotency checks and processing the message. But ultimately, it is a trade-off. If you want us to cover any specific design problem, please let us know in the comments, and we generally have pretty good turnaround. Please subscribe to our channel and like the videos to support us. Also, we value criticism a lot, so whatever doubts to criticism you have, please make sure you add it in the comments.